So there's many different shapes I could give you. Refer to problem 29 for all the shapes I might give you. Other shapes exist too, but for fall of 2013 at least, I'm going to restrict myself to one of those 5 if I pick this problem. And the solutions to all 5 are given in the answer key. So I'm going to just do out the solution to this particular one. And so that means there's 5 possible problems, but they can go each in 2 directions, except the dodecahedron can only go in one direction. That is, we can start, we need this number, 720 degrees angle deficit total. You're going to need that information. That's your total angle deficit for objects that are solid like this and do not have any holes, such as donuts, or you know, those figure 8 donuts with 2 holes in them. Okay, so those don't count. You can't do that. But if you have a solid object with no holes in it, then they will have a 720 degree total angle deficit. And what this question is asking is, it's asking calculate the number of corners, otherwise known as vertices, if you already can visually look and figure out what is the angle deficit per vertex or corner. You see 5 equilateral triangles come together here, and at each vertex it's the same. So 5 times 60 degrees for each of those triangles is equal to 300 degrees. And the point is, if it were 360 degrees, it would be flat. But what we do is it's like we took a flat piece of paper and we cut out one of these you cut it into 6 equal pieces, each 60 degrees. So we have a 60 degree angle here, a 60 degree angle here, 60, 60, and we cut out one of the pieces and then we fold, and this is what we get over here. That's exactly what happened right there. So what we're going to say is this empty space is the angle deficit is equal to 360, which is what it would be if it were no angle deficit, minus 300, which is what we have, is equal to 60 degrees. Okay? Now, step 2 is we have the total angle deficit, which is 720 for all the shapes. Divide by 60 degrees, and it tells you 12 vertices. So you just write 720 over 60 is equal to 12 vertices. The other thing I could have done is I could have given you the picture of the icosahedron that is see-through, and I could have given you the instructions, count all the vertices, then using that information figure out what the angle deficit is per vertex. So in that case, you would not have found the angle deficit using this mechanism. You would have found the angle deficit this way. You would have said, aha, 720 is the total angle deficit divided by 12 vertices is equal to 60 degrees per vertex. Okay, so quite honestly, if I'm going to give you the icosahedron, I'm going to do it in this direction. But if I give you the dodecahedron, it'll be in the reverse direction. So the dodecahedron, what will happen is you would have to either count, or I'd have to tell you this number down here would be 20, and then this number here would end up being 36. So you'd be 720, so you'd just type into your calculator, you go 720 divided by, and then 20 would give you the 36 degrees. Okay, so that's how you would do it if it was if it were a dodecahedron, because I have not talked in class in fall of 2013. I've not talked about the number of angles in a regular pentagon. That's something I've done in previous semesters and probably will do in future semesters, but we didn't get to it. And so we can't start our problem from that place because we didn't cover that material in class. But we can do the reverse problem, and we can do all the other shapes in both directions. Okay?